All right, so now we're talking about the second of the three parts of the triple constraint, which is time management. What we're really talking about here is schedule. How do you create a schedule? Manage the time that you're allotted between the time that this project has to be done and the time you start. What do you do with everything in between in order to get the deliverables accomplished and the scope completed? So project schedules, basically time management. This is what we want to keep in mind with time is of the three, it really has the least amount of flexibility by physics. So, you can't really get more time. If there's a deadline for this having to get done, typically that's driven by either financial needs at the end of the year, end of the quarter, or you've got some sort of other project that's coming along that needs to start. So time doesn't have a lot of flexibility. You can change your scope up and down. You can change your cost. A lot of times, this is IT, so obviously cost changes a lot, but time is the one thing that you really need to manage. So of these knowledge areas that you see, this is the one you're going to spend a particular amount of time on. And keep in mind, people don't typically get, in general, people don't get fired because they went over on cost or because, the scope changed or something. People do get tired if they get fired if they don't get something done. So time is a critical one. Of the three, this is the one that has the least amount of give. The processes that we do with time management, when you're creating a schedule, you find the activities. A lot of what we did in the WBS, now we're going to be translating into actual tasks. You sequence those, so what order do they need to go in? You estimate those to see what how many resources are needed. Then you estimate that given those resources, how long is each of these things going to take? And then you take all that, put it together, and do that schedule development. And then once you've got the schedule, then you do the schedule control, like we talked about in the last week. Everything that you created now, there may be changes as we go. We've got to be able to configuration control that schedule moving forward. So activity definition, let's go to the first part of that. We take our detailed WBS, our work breakdown structure from the scope activities, and we define all the attributes associated with each of those tasks. What needs to come before it, what needs to come after it, what are the relationships, lead times, lag times, those kinds of things, what are the constraints, so that you can understand each of those activities. Let's talk about milestones a little bit. A milestone is a significant event. So these are important aspects of your schedule. It doesn't have any duration typically, and in fact in Microsoft Project, if you enter a task and make it 0 time, it automatically becomes a milestone. But it takes a lot of several activities come together to form some milestone. It's typically something that you use for setting goals and monitoring progress. Milestones should be specific, measurable, assignable, realistic, and time-framed. Those are the SMART attributes. Obviously, we talk about those in the class, but what you're trying to do with milestones is try to put things in the schedule that will tell you as you go, are you making the progress that you need to make? So sequencing and dependencies, whether they're for milestone or whether they're just sequencing the tasks among themselves, what you're trying to do is look at the dependencies for each of these tasks. Dependency can be a lot of things. It can be mandatory, like you need to have hardware before you can start installing it, right? So you need to do the purchasing before. It can be discretionary, like you may know that this particular person is the person you need to do this. So you just wait till their availability, then you schedule that in. And there can be external ones too, like regulatory dates that you have to have things done by, permits that you have to have put in, those kinds of things. Any of those things are dependencies, and you got to reflect those in the schedule, make sure you've captured those. There's lots of different ways you can capture them. One of them is network diagrams. So here we've got a schematic of called a activity on arrow kind of diagram. And what it basically says is there's these states of the project, and there's all these tasks that have to happen. And these three can happen at the same time. And basically you go from 1 to 3. This takes 2 days, this takes 1 day, this takes 3 days. And as you go through, you can see as these things may be happening in parallel, but some of these are dependent on each other. So 5 can't go until E is done and D is done, and then it can move. So what happens is you build basically a critical path that says the longest thing that's going to happen is this line of tasks right here. That's going to take this particular line. So now you can start to see there are some critical paths that if I work to that length, I can reduce the overall duration of the project. Precedence diagramming, another way to do it, this is what your Microsoft Project generally does. You line each task saying task B can't start until task A finishes, or task B can't start until task A starts. They can both start simultaneously, but one has to start initially before the other and start feeding it. There's lots of different ways that you can organize these. This is basically how MS Project does it. Now you get into estimating. So before estimating can occur, You want to have a good idea of the quantity and the type of resources that are going to be at your disposal that you can assign. So each one of these, as you assign those resources, you're going to have a duration, which is basically the amount of time worked on the activity plus any elapsed time related to it, and then effort. And they're two different things. So if you have two people working a task for 40 hours, it's an 80-hour task, okay? But the duration may only be 40 hours. So in terms of the work and cost, you'll have a different effort than you have duration. Now, how do you create these estimates? A lot of times this comes from experience. People doing the work should help create the estimates, number one, because it gives them buy-in, but also because they generally tend to know what they're doing. So, instead of providing activity estimates as a discrete number, when you're doing the schedule, what you want to do is what we call a 3-point estimate, the PERT average. And what that basically says is engineers and developers tend to see the end product. We don't tend to see all the problems that we're going to encounter because they're unknown when we start. So we tend to estimate how long we think it'll take and we tend to be a little bit optimistic. So what you want to do is take what people say is the average time or what the time that'll take. Ask them for an optimistic time. Ask them for a pessimistic time, and then the most likely time. And this is how you do the equation. Then you do PERT. You say basically optimistic plus 4 times most likely plus pessimistic, divide that by 6, you get an average. So where the optimistic time for this one is 8 days, most likely is 10, the pessimistic time is 24. And that can be very different. So pessimism may say, look, we don't get this permit and it has to take us, a certain amount, a whole lot longer. That can be the most pessimistic, but go ahead and add that one in. So you think it skews, but in reality, across the entirety of the project, this winds up estimating pretty well, because for every task that goes fine, every 4 tasks that go fine, you're going to have one that, hey, that went well, and you're going to have one that really went bad. And so at the end of the day, you wind up coming up with some pretty good averages. From that, we start to develop the schedule. So that's just creating these tasks, assigning all the activity and the details about them, and putting them into a PERT schedule here, or into a Gantt chart here. It kind of visually lets us understand what's going on. Black diamonds typically are milestones. Thick black bars are summary tasks, so a group of activity like development, right? There'll be a bunch of subtasks under that. And then arrows basically between tasks show you where there are dependencies. So we talked a little about critical path. Critical path method, remember this as we go forward. This is important. This is how you determine when you're trying to crunch the schedule back, you can reduce the timeline, you can reduce the slack, you can reduce some things, but you can't reduce the work that needs to get done. So you've got to figure out what is the line of tasks here that I need to work on the most. If I'm going to put more people on it, if I'm going to do something, what is the line of tasks that if I reduce that one, it'll actually reduce the length of the project. If I reduce any of the other tasks along this line that aren't on the critical path, it doesn't matter. The critical path is still going to push me out to the same time of completion. So critical path method is the key way to look at that. When we're doing scheduling, we want to avoid, and I will keep poking you on this throughout the term, reduce multitasking. Multitasking is an attractive thing, especially for a project scheduler, because you can get a whole bunch of tasks started. And so you look like you're making great progress. And it makes people happy, makes the leadership happy, that all this stuff is moving. But the reality is what will happen is all that stuff will slow down significantly, because you can claim credit for a lot of stuff starting, but as you can see as these tasks go, you're not getting stuff done. And what happens is you'll start to see these dependencies start to creep up that you weren't even expecting, because the people that are working these things can't get everything done at once. If you look at the way we laid this out, you've got task 1 is going to take 10 days. This one's going to take 10 days. This one's going to take 10 days. If there's a little bit of a gap in between where you're having to switch, people have to go switch and get their stuff together for the next one, and that's what it takes. By the end of the 30 days here, you've got task 1 complete, task 2 complete, and task 3 complete. The project is moving forward, right? If you multitask, see the person starts task 1 and you say, hey, we got to make more progress. Start on task 2 too. Just get it started. Oh, get this one started too. That's fine. He's having to switch between each one of these things, get all the material, get everything that they need. Then he switches back to task 1. By the end of the 30 days, you've actually got only one thing done, and that's task 1. Whereas by the end of the 30 days up here, without multitasking, you complete the whole thing. So remember, this is true for multitasking, and it hits big projects for big contractors all the time when people forget this. Good practices for schedule control. Keep reality checks on the schedule. So first draft is just that, right? You've got that in the charter. Make a more detailed one, get it realistic, make sure it stays followed. Don't get caught in the trap of trying to please someone with a schedule. Make it reality, and so you can work to it. Allow for contingencies, put buffers in there. Don't pad tasks, okay? Because that just makes you unreliable as an estimator. But put buffers in that will let you absorb the risks that happen, but also still understand how good your estimates actually were. Don't plan for everyone to work 100% capacity. It won't happen, okay? Plan for 80%, availability. Make sure everyone understands and the issues that are happening, and scheduling issues should be alerted. There should be alerts immediately. If there are issues with the schedule, make sure everyone's aware of them. Use the tools and techniques that we're talking about here in the class to make sure that we're trapping them. The big thing to keep in mind in the OODA loop, I talk about risk and buffers and stuff, is this decision loop. So when you're going through a schedule, what you're trying to do is make sure that as we're managing this project, whereas we're seeing it happen, we're seeing changes that come up, we're seeing problems that pop up, we have the time to orient ourselves, we can decide on those and take action. What we want to do is make that as quick as possible. Having a good schedule and understanding who's doing what within the schedule helps you to process this thinking loop. In the OODA loop here, I put a little description in here. This is basically the process by which you go through when you're managing the schedule. When you're not in control of events, events are going to be in control of you. Basically, it gets inside your own decision loop, and you can't react quick enough to keep these cascading problems from happening. So move fast enough to keep control of the pace of events. Keep your schedule in line, understand what's going on, and manage that OODA loop. So the keys for project management: communication of events and activities, manage that communication, keep your change control solid, okay? If you do those things, then you're completely oriented to what's going on in the project on a continual basis. You can understand the ramifications of these activities. Do good risk management so that things aren't surprising you. If you know what's potentially out there, you can be mitigating it in advance and thinking through what you need to have in the schedule and what kind of buffers you need to have to be able to manage things as they come through. You need to be moving continually on this. Good team actions then can be acted on based on good schedule management. So you've got good relationship with the people, you got good supply. We're going to talk about people management and supplier management a little later. But all this thing is in the action side. The schedule, management of the schedule, management of time allows you to coordinate and to maintain your overall burn down on the schedule as effectively as possible. You want to manage your percent complete, which basically is the easiest to track kind of thing. This is what the schedule will do. There's also, burn down techniques that allow you to if you just want to put all the lists to tasks out there and start burning them down, you can track them that way too. That's what agile software techniques do as well. Either way, what you're doing is managing that schedule and making sure you're getting the things done that need to get done. If there's problems that pop up, work the critical path method. Remember, that's the first thing. Find a critical path, focus on that. Crashing means add more resources. Now that's going to increase your costs, but you can add more resources to try to make things go faster. Fast tracking means maybe there's some things you can work in parallel and break the tasks up so there are parallelized things that you can do and maybe reduce some of the length of some of the other tasks. Sometimes it means more rework, right, or more context switching. But oftentimes that's just maybe what you need to do. It isn't as clean, but if you can get the focus there, you can maybe do some parallel activities. And lastly, if you can't figure out those things, examine your scope. As things get closer to the end, you'd be surprised. Some requirements that were really important just aren't quite that important when you actually get to finish this thing up. They see the acceptance criteria as what they really need, the major criteria need to get done. And some of these things start to drop off in terms of their importance. So those are the key things to look at in time and schedule. And we'll start building the Microsoft project schedule based on what you saw in this presentation.